when I say create node, when I'm using the notation node, I'm referring to the linked list 2, which is the bottom one, right? And when I say create express node, when I say create express node, then I'm referring to a node which belongs to the express lane, which belongs to, this is the convention I'm following throughout this particular chapter, okay, throughout this particular unit. So what I'm doing, cur, right? What is cur? In a global area, I have defined hash node cur. Okay, just a minute. Oh, नंतर कॉल करतो म्हणून सांग. So the node structure. What is this node structure? The node structure is struct node, a type def struct node, right? Structure of the node. It has got the facility to store key, and it has got the facility to store value, and there is a pointer pointing to the next. The pointer pointing to the next, and then the node, the cur, as a pointer of struct node type. Now, if you notice, this is the variable, right, which is struct node type, and because I have used the keyword type def, henceforth I need not have to write struct node cur first, last, like that. I can simply use this particular variable node and create a pointer which is of struct node type. Is this point clear? The type def, the idea of putting a type def is to reduce the code. Why we reduce the code? Because we reduce the chances of typographical errors and logical errors, right? So instead of every time writing struct node cur, struct node first, struct node last, like that, we in one go we say type def node. So it becomes a user defined data type, and for further referring to this particular struct node, we simply say node and say cur. Okay, so this is my structure which is belonging to the normal linked list, that is the node. Next, I have the express node. Now, yeah, sorry, express node. So type def struct express node. Here I have a level, I have the key, I don't require the value. Then I have struct express node, express next, struct express node down to go to the one express level lower, and struct node pointer next. This particular pointer is to go to the node from level 1 express node. Are you guys understanding? No. Why the complete structure? It's very important that you understand this structure, because the complete code is depending on how well you understand the express node structure and the node structure, because we'll be utilizing it at several places. Anybody who has not understood, see, this is this level. Let me see. This is your normal lane, the lowest lane. This is your lane 1. This is your lane 2. This is your lane 3. This is lane 4, and this is lane 5. So this can go up to the level which is required. There is no limit for that. As per your application, you can go up the level. So this is your normal lane, express level 1, express 2, express 3, express 4 and express 5, right? So I'm talking about this particular node, right? Now if you look at the diagram, now here firstly I have a key which is 12, and that key, because it is a part of your express lane, the key which is there in the normal lane has to be repeated in the express lane, right? The key which is there in the normal lane has to be repeated in the express lane. I hope you guys are understanding, because all the elements which are in normal lane, some of them are part of the express lane, right? So in the normal lane, if the key is 12, in the express lane it has to be perforce 12. Okay, so you should have a provision for the key. That is what I have created in the structure. Then you should have the provision for this is level 1, this is level 2, level 3, level 4, level 5. So you should have a provision that in which lane you are looking for, therefore that level. Then the express node 12 is connected to express node 17. So how will it get connected? So you have to have a pointer which is express node type. You have to have a pointer which is express node type. Therefore that express node next, right? So that is the pointer which I have created in the express node. Next, if you consider this particular node, now this node 17, this node, if it has to come down, then it has to have a pointer which is express node type, right? I said down because I am going to store to come down one level. Therefore, I have named it as down. Students, are you able to understand? Now, this particular express node should have a pointer which is pointing to the base address of another express node, but I have mentioned it as down so that you can come down one level. Now, third, you have to have one more pointer. And that particular pointer is pointing to the node, because these are all nodes. These are express nodes. From here upwards are all express nodes, and only in this line you have node. Any clarification regarding understanding of this diagram? Now, one thing I have missed, minus infinity here and plus infinity here. So what we assume is that the very first node in all the layers is taken as one huge negative number, in case you are considering a integer type of data to be stored. So huge negative number is the first and huge positive number is taken as the last node. So it makes the handling of skip list little simpler. Therefore, the very left extreme node is taken as one huge negative number, and extreme right express node and the normal node key is taken as positive. Students, are you understanding this? Anybody who is not understanding this, please come in the chat window and pose your question. Do not feel shy. Okay, Siddharth, it is like this. The bottommost is actually the linked list which we are looking for. Means the actual data is there in this linked list. But to have a faster search, when we are talking about the billions and trillions of records, right? We are dealing with billions and trillions of records. Though it is sorted order, unfortunately if it happens to be the last element, then you have to take 1 billion iterations to reach the last number, isn't it? So to avoid that, we have some algorithm called as skip list. And what is this skip list algorithm? So this skip list algorithm, it will have layers of sorted linked list, one above the other. So the leftmost node in the normal lane and all the express lanes is taken as huge number which is on the negative side. So we call it as first also. And the rightmost, we take it as huge positive number, which is not going to be part of our linked list, right? So to have the extreme left and the extreme left and the extreme right, we start this. We start making this assumption. Okay, and yes, Siddharth. Okay, now I was explaining you about the entire structure of this express node, right? Express node. So I took one case. This is the 17. This is the express node level 2. This is level 1. This is level 2, and this is our normal lane. Okay. So the express level 2, right? Level 2 has got 17. Few nodes are arranged upwards in between, right? Are those done by us, or it is done by system, that is by the code by default? Yeah, Siddharth, it is like this. It is like this. It is done by us. It is done by us one way. There is one more logic called as toss the coin. There is a one more algorithm called as toss the coin. What is this toss the coin algorithm? First I will deal that, and then I'll come to what you are seeing it in the figure. Now toss the coin. The probability when you toss the coin, the probability of getting head, right? Yeah, all of you have seen Virat Kohli tossing the coin for before the match begins. So the probability of Virat winning is 50, 50, isn't it? Because there are only two sides of the coin, so 50-50. Okay, so every time we do some random kind of a we call a random number, and through some algorithm either it is 0 or it is 1, right? If it happens to be 1, then create a node in the express node. If it happens to be 0, do not create. That is one logic. The other logic is that you ask the user, do you want level 1 or 12? If he says yes, then create. Again ask to 20, do you want level 1 or 20? If you say no, then skip. If you ask 38, right, do you want a level 1 node? Yes, then create. Skip, create, skip. So both the logics are there depending on your requirement. One, the system doesn't create, you have to do the coding. You have to literally do the coding and include the express node. Siddharth. So that is done by user choice, sir. Yes, that is done by user choice. So for user choice, there are two options. One, through a random number, random number, right? It can generate any number between minus infinity to plus infinity, right? So that number, through some algorithm, you should bring it either down to 0, that is if it is odd number 0, if it is even number 1. So the probability of generating an odd number to even number is 50-50, right? So that is one logic. The other logic is, every time you ask the user, do you want express node for this particular node? If you say yes, create. Right. So let me explain the structure. Siddharth, in case you are not understood, please put the question. I am happy that you took some time, typed out the entire text, and this must be the doubt lingering in a lot of students' mind. So in case Siddharth or other students, if you are having some kind of basic doubts, if you understand the skip list structure, you can code. If you do not understand the skip list structure, no matter how correct code I give it to you, but you won't understand that. And not understanding is the worst thing for a EC for a CSE and IT student, right? Now I was coming to the structure of this particular node. Now if you look at that, this is a key is 17, and corresponding to this 17 key there is some value stored over here. Okay, now this node has to get connected to the next node, and this node happens to be an express node, so there is an express node pointer here, right? Now this particular node also has to be connected, this particular node has to be connected to a lower level express node. So again, the pointer over here has to be a pointer which can store the base address of an express node. Just to differentiate, I have said next and I have said down. I said next means in the same level, next node. Down means express node but in the down level, right? Then this particular node requires a pointer which stores the base address of a normal node. This is not an express node. These are all normal nodes, right? So this particular node has to have a pointer which stores the base address of the next express node, and this node should have the pointer which stores the base address of a normal node, right? So in this case, the down node has to be null and the normal node pointer has got the value of this base address. Okay, so keeping this particular diagram in mind, I have a provision for level, I have the provision for key, I have the provision for this is express node next. This is meant for what? Any of you? Siddharth, say. This pointer is to store what? Base address of express node not node, the present in the same level. Yeah, okay, Siddharth, we are calling not as node, we are specifically calling it as express node in the same level, right? Node we will call when it is in the normal lane. Okay, now this down, what I mean to say, struct express node down, this is meant to go one express level down, right? So it is going to store the base address of express node only, and this NXT from express node level 1, you have to go to the node level 1, right? So this is meant for that. Okay, so that is our structures of express node, and this is the structure of your normal node. A normal node has got the provision for key, the provision for value, and the provision to go to the next node. Right? Okay. Now, when I want to, sir, is it struct node NXT or node NXT? It is node NXT. I wrote a node only, no? Struct node. It is node NXT. Sai Gautam. Why node NXT? Because I'll take you to the diagram. See, this particular linked list is your normal linked list. So only nodes are there. From here upwards, all express nodes are there. So the third pointer in this express node is pointing to a node. The third pointer is pointing to a node. Therefore, it has to be struct node. Gautam. Okay, Gautam Verma. Right. So now, when I create an express node, I can create an express node means I don't just create, I have to populate it. I don't create, I have to populate it, right? So I'll call this particular create express node function. Before that, let me go to create node function. So the create node function, cur. What is cur? Cur is a pointer of struct node type, right? Cur is a pointer of struct node type. You have seen it in the previous slide. So this is a malloc size of node. What is node? This is the name of that type def. Name of that type def is capital NODE, and is a pointer of node type, right? So you create one isolated node, you create an isolated node, and in that isolated node, you are asking the user enter the key. You are asking the user enter the key. Assume that the user has entered 10. Then you are asking the user to enter the value corresponding to the key. Suppose the user has entered 1111, right? So since it is an isolated node, I am initializing that to cur of next. What is this cur of next? Cur of next is going to store the address of the next node. Is going to store the address of the next node. So presently in an isolated node, I have connected it to null, right? I have connected it to null. When you insert actually into a list, that is the time you allocate the value. Is this create node method clear? Anybody who is having a doubt regarding create node method? Right. See, it is like this, Sufrit God, that dictionary, actually the entire unit, we are talking to have a dictionary data structure. And what is this dictionary data structure? The dictionary data structure, in fact, I had done it in the previous class, therefore I did not start from there. Anyhow, since God has asked the doubt, Sufrit, it is like this. A dictionary is a pair. What is a pair? A dictionary is a pair means what? Connected to a key. Connected to a key, there is a specific value. Connected to a key, there is a specific value, right? So if I get the value of the key, then I can go to a value, right? So a dictionary is a combination of two things. One is the key, and corresponding to key, what is the value? So if the key is 10, the value could be 1111. Sufrit God. Not three values. Corresponding to every key has got only one value, and all the keys have to be unique. The values may or may not be unique. We can't store three values here. Only one value corresponding, one key and one value. Where are three things we are seeing here? Akashdeep. In this structure, we can store three values. How three values? You can store only one key and corresponding to that key, only one value. And the keys have to be unique. The keys cannot be duplicated. Sir, can you show the express and normal node diagram? Okay, you want to see the diagram? Right. I'll show it this way. Do not look at the code and unnecessarily get confused. The express node. This is the express node. Level, say 1. This is the extreme left. This is the extreme left key, which is 9999. Express next, right, is connected to the next node. Express down, right, because it is level 1, I have initialized to null. Now this is the normal node. This is my normal node. This normal node has got the key called as 9999. This key has to be exactly same as this key, and the value corresponding to this presently has been taken as minus 9999. Raghavendra, are you clear about the express node structure and the normal node structure? key value and next. Akashdeep, hold the doubt. I'm coming to you. Let me first complete Raghavendra. Sir, where is the value located in the linked list? Which linked list you are talking, Raghavendra? Express or normal node? Normal node. Normal node, this value is there, no? Raghavendra, this is the key and this is the value. This is the key and this is the value. This is the extreme left node. Therefore, I have taken the key and the value as same. We are relating the key to value and next. Jai Shankar, let me explain. You don't have, please, none of you make cross talks, otherwise there will be a confusion. Raghavendra, what Jai Shankar is saying is correct, but Jai Shankar, let me answer the student. Otherwise, what will happen? The cross talks will create confusion. So none of you, without my permission, do any cross talks. Raghavendra, what actually Jai Shankar is saying is correct. See, only the node will have the value. Only the nodes will have the value. All the express nodes will only have the key. All the express nodes will only have the keys. So value is there only in the normal node. Raghavendra, are you just saying okay just for the sake of it, or have you really understood? That's the reason why I have two structures. One structure for the node and one structure for the express node. Express node has got a pointer NXT. That NXT pointer is storing the base address of the normal node. Right? Express node, express next is going to store the base address of the node which is in the same level, and this pointer down is going to store, it is also express node type, but if it is in level 2, then this is going to store the base address of level 1 node, level 1 express node, level 1 express node. Okay, thank you Raghavendra, if you understood, that's great. Now let me come to the other student who was asking something else. Raghavendra is done. Who else was there asking some question? Akashdeep, key value and next. What do you want regarding this, Akashdeep? Key value and next. What? Akashdeep, you just put key value and next. Thank you, Raghavendra. Good. Do not feel shy. Sir, I am asking that in structure node we are scanning two values. Where are we scanning two values? We are not scanning two values. We are scanning only one value, friend. For a key, this is the dictionary structure. A key has got a value. Every key, the keys are going to be unique, and the values connected to that key could be unique or may not be unique. Sir, I am asking that in structure node we are scanning two values. He meant in linked list. I don't know, I'm not still understanding Akashdeep's doubt. Suprit is saying in skip list we wanted to tell that the node contains three values. Which three values? I am still not. Are Are you referring to the diagram which I had shown, minus infinity to plus infinity? That diagram, are you referring to that, Suprit Gaud? Akashdeep, not Gaud, Akashdeep. Is the confusion there? Can you once show the diagram structure node slide? Okay, fine. The diagram of struct node slide. Yeah. See, the struct node starts from here. It has got one key, it has got a value and a pointer. Where are three values here? Key, value and a pointer. Akashdeep. So the Akash question is that in linked list, there we have only two value, that is data and next. Okay, yeah, in the linked list what we have studied previously. Oh, that way three values you are saying. Okay. Okay, I got the point now. Yeah, I got the point. Okay, fine. Okay, the confusion is that in the previous class, till the previous class, we are considering only one data and one pointer. But that time I had told Akash that do not get away with an idea that a linked list will have only two things. It can have several things. Like your struct node you saw, it had got a level, it had got key, it had got three pointers. So totally three pointers and two values, that is five values, right? So if you are considering three values like this, value 1, value 2, value 3, are you considering like that? Value 1, value 2, value 3. Akashdeep, okay. Yes, we are storing three things. Three elements are there. I will not call it value because value is a name of the element over here. Therefore, I am not calling it as value. I am calling it as elements. In this structure, we have three elements in the data structure. Yes, we have three elements in the data structure, and in this express node, we have 1, 2, 3, 4, 5 elements in the data structure. So this node, whether it is express node or a normal node, not necessarily it will have only two values. As per your notation, it not necessarily it will have two elements. It can have two elements, it can have 20 elements, it can have 200 elements also, depending on your application. So just now you have seen the express node is having 5 elements, whereas the node is having 3 elements. Because the requirement of values which are getting stored, the requirement of data which is getting stored are different. A normal node actually stores the key and the value, whereas an express node, it stores the pointer to one of the normal node linked list. Akashdeep, is that three values problem clear? Okay, thank you. Right. So when we call an isolated node, by creating by calling this create node. If I call this create node method, first I am creating a cur and I am assigning a base value. The cur is already created in the global area, so I am straight away using it in this function cur, and I am storing the base address. Then I am asking the user to enter the key value. Then the user enters. That I am showing cur of key, right? Arrow operator key. Then I am prompting the user to enter the value corresponding to this key. For example, 9 minus 999 is the key. Then he is prompted to enter the value. So he has entered minus 999 again. So that goes to cur of value. And the cur of next, presently it is initialized to null. So this is the job of my create node. Similarly, the job of express node is that enter the level, right? So express car of level. Then I'm asking the user to I'm asking the user to any one of you. What is this cur of key? Any one of you? Yeah, shuttle is trying. Sai Gautam is trying. Cur of key. Current key. Key in normal lane. Excellent. Yes, Aman Singh Jolly, you absolutely defined it very well. Key in the normal lane. Key in normal lane. Raghavendra is also understood. Key in the normal lane. Node lane key. Very good. Desai. Absolutely right. So therefore, I'm not taking it from the user. I'm taking it from the cur of key. Right? Why? Reason is I if you notice, if this is the key 17, right? If I ask the user enter the key, by mistake instead of 17 he put 70, right? So it is totally mismatch. So I'm not giving any chance for the user to make a mistake. I'm picking up this key corresponding to this key, corresponding to this particular node. I want to have an express node, right? But if you see the diagram, in the levels which are above, when the levels which are above the normal lane, all the keys have to be same. All the keys have to be same. So this 17 is a key, 17 is a key, 17 key, 17 key, and 17 key. So that's the reason why in this create express node, I'm not giving a chance to the user to make that mistake, right? So cur of key, so first thing what you have to do, you have to have a normal node, right? That normal node is going to have a key. Corresponding to key, I want to add one express node. For example, corresponding to 17, which is a normal node, I am asking to add an express node. So the express node, if I add, the express node have to have the same key. Therefore, I am picking up cur of key. Now, express cur, express next null, right? I'm creating an isolated node, initializing it to null, right? And yeah, so this is how I'm calling the create express node. Students, I told you to simultaneously type the code. Have you done it? Start from here if you have not done it. Start node, express node. Please type it in your editor. And please make it fast. Do not type the one which is commented. And also do not forget, in the global area, these are the pointers which I am declaring because we are going to use these pointers. We are going to use these pointers. Completed? Okay. Next, please type the structure of your normal node. Int key, int value, struct node pointer next, and give the name as node. And also declare previous car, first, last, start, temp1, temp2. Cur is a temporary pointer, last is the last node pointer, and first is the first node pointer. And in between, we will be using temp1, temp2. So this is the structure of the struct node. Now coming to your create node. Complete this method. Create node. You are done with that. Then go to next. Are you ready? Okay, I'll call you to start. Then you take over. I'm slightly in the middle of some explanation. Yeah. Previous slide. Create node. This one you are talking, Yogeshwar. Yogeshwar, are you talking about this? Okay. Tell me when you finish. Okay. Anybody is still not something which is commented, please don't write. For example, last two lines. No need of writing those last two lines. I have commented that for some explanation later. So don't unnecessarily waste your time in those commented lines. Okay. Now, in the next class, that is day after tomorrow, I am going to deal with some of the functions which will going to initialize the skip list 1, which is going to insert this list, insert the node and the express node, and also display and search. Okay. Now the strategy, please try to understand the strategy. The initialization will have the left extreme node as this, which is minus infinity. In our case, I am taking the minus infinity as minus 9999. Key and value both. Students, minus 9999 is not infinity, I know, but just for the sake of simplicity, I am taking the negative left extreme as minus 9999. Now this node is a kind of a very indicative the leftmost extreme, right? It is not a part of the linked list, right? It is not a part of the linked list. It is just indicating the leftmost node. Similarly, this is my rightmost node, right? Which is not a part. The actually linked list start from this 12 blah 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 50 and upwards. Okay, this is just the marker which marks the rightmost node, Okay, so rightmost positive 9999 is the value of the key. Correction, is the key and the value. The key is plus 9999 and the value also is 9999. Then keeping the moment I start adding, I start adding the node first, right? And we can ask the user, do you want an express node corresponding to this node? For example, in this case it is yes. If it is yes, this node gets added, right? When 17 is getting added, I'm just telling you the algorithm. When 17 is going to get added, that is the time, since 17 is higher than 12, I will add the node here. Suppose if the next time I ask to add a node and that node happens to be 16. Students, are you understanding? Firstly, the first node is 12, the second node is 17. So it's already 12 and 17 in the sorted order. But in the next time when I ask the user says 16. Then I will have to create a node here. So instead of creating the node and then sorting, while inserting itself, we are going to sort the node. Are you clear? The strategy I am talking about. If you know the strategy, then you can relate the code when I am going to explain you the code next time. Once again, suppose the first node is entered is 12, the second node entered is 20. So 20 is added to the end, right? So my linked list is going to have minus 9999, 12, 20 and plus 9999. Now I ask the user, do you want to add a node? He says yes. Then if he gives me the value 17, then I'm not going to add 17 here, but I'm going to add the 17 in such a manner that presently 12, 17, 20 are in a increasing sorted order list, right? So we are not going to add a node here and then sort it, but while adding the node itself will sort and do the job faster Now suppose the user asks corresponding to 12, do you want an express node? Now the express node left extreme is also minus 9999 and the express node right extreme is 9999. Presently only the normal lane has got minus 9999, 12, 17, 20 plus 9999. Here if the user says I want to add one express node, so minus 9999 and 12, right? This minus 9999 will have a next express node pointing here and any NXT pointing to this node. Similarly, this express node is going to have a node pointing to the next node and a pointer pointing to the normal node. Here again I ask, I add here. Here I ask, he says no, I don't want. The next node is added is 25. So this is the strategy which we are going to keep it at the back of our mind and then start inserting a node, searching a node, deleting a node. Any doubt so far up to what we have covered? The structure of express node, the structure of normal node, the extreme left node, minus infinity. For the sake of simplicity, minus infinity we are considering as minus 9999. The rightmost node, positive infinity. At positive infinity, for the sake of simplicity, we are considering as plus 9999. Create node function, create express node function. All these points. Any clarification, students? Please do not feel shy to use the chat window and clarify your mind. Unnecessarily, you will be harming yourself if you keep shying. Yes, Raghavendra. While creating nodes, we are sorting it. Absolutely right. When we are writing the node, we are inserting node in such a manner that the list is always sorted, because this is the principle on which the skip list concept works. At the normal node linked list, it is in a sorted order. Express nodes level 1, level 2, level 3 all are in a sorted order. So as Raghavendra is saying, while creating itself, we are sorting it. Anybody else? Any clarification? Yeah, Shankar, take over. I'm announcing. Okay, so the second part of your is binary search better skip list. See the search time or the efficiency of a binary list, right? And the efficiency of skip list is more or less same, right? If you really compare the efficiency wise, efficiencies are time complexity and space complexity wise, both are same, but the data structures are different. Raghavendra. Okay. So we are going to the second part. Shankar sir is going to take over. First, he will explain all the questions in the previous quiz, and then you will take on today's quiz. You want me to stop sharing? Okay. Okay, stop sharing. Yeah, can take over.
Yeah, hello guys, good afternoon. Can you able to listen my voice? It's very low. Guys, now right now how is my voice? Can anyone able to listen my voice? It's easy. It's audible. Little louder, okay? Yeah, guys. Yesterday we connected one quiz, right? So in the quiz, a lot of students got 100 of 100. I mean, so 15 out of 15 questions they attended. So this is the result, right? Yesterday 449 is login. In that one, 183 is a normal grade. Means it's a between you can call as a 80 to 90, 95 in between. These are 189 students who got 100 out of 100. Can you check it? Yeah, these are students who got 100 out of 100. Okay, before I'm going to quiz, I given the 15 questions. So these are the questions. Okay, the first question I given is in which data structure element is inserted at one end, insertion at one end, and deleting at another end. So in which data structure element is inserted at one end called rear and deleted at another end called front, right? Suppose this is an queue. So it's an this is called a stack. So insertion happening here. This is a ticket counter. I can call collecting tickets in the queue. So everyone is coming here. The first person, the second person, the third person is came, and fourth person is came over here. So this is totally completed. So this capacity is 4 only. So I'm inserting at one end. Yes, insertion is happening here, right? Here the person is coming over and entering here, and deletion is going out here. So inserting at rear. So we are inserting from rear, and we are deleting from front. So this is an example for Q. So what is the option? Which one is the correct answer? What is the correct answer, guys? Which one is the correct answer? Q, right? Rohan, correct. It's the correct answer. So second one, the process of removing an element from a stack is called. The process of removing an element from a stack is called. It's a pop, right? We are removing from element from a stack is called a pop. Yeah. The process of inserting an element in a stack is called. It's a create or push. What is the difference between the create and push? What is the difference between create as well as push? So suppose already this is the size is fixed one, right? So what we in the stack we are going to inserting some element. Not we are not allocating some any memory, right? So what is the meaning of create? Creating is allocating some new memory. So we are not using the creating term. So terminology of create is allocating something new memory, right? So this is a wrong answer. So push is an element is used to insertion. Okay, so answer is B. So in a stack, if a user tries to remove an element from the empty stack, it's called, suppose stack is an empty, right? Right now presently this stack is empty. This stack is an empty. So this stack is empty. So if you want to try to remove an element, I cannot remove. So this is called an underflow. So option A is the correct answer for this one. Next one, pushing an element in the stack already having a 5 elements and the stack size is 5. Suppose I am written is 4, right? If there is a size is 5, 5 is it. So already 5 elements are there. So if I want to push an element here, so can it can possible? No, because it's an overflow. Already done is overflow, right? Our next question is a queue. A queue follows which rule, which principle we can call first in, first out, right? FIFO rule, not LIFO. LIFO will comes under queue, which comes under LIFO comes under stack, but FIFO comes under queue. Means first in, first out. The person who entered first completed, then he has to go out. Next, queue serves major role in recursion. No, it's an arbitrary linked list. Queue is not a linked list right now. So it's an allocating memory. This is limited resource allocation. This is the right answer. Not a simulation of heap sort. We are not talking about sort, right? A function which call itself is called a dash function. What is the answer? It's called recursive function because a function, suppose I written some function here, some function I written here, some function, whenever coming out and when again I am calling this one, it's called an recursive function, right? Next question is a linear list of element in which deletion can be done from one end and insertion can be placed only at the other end. Where? What is the answer? The previous question, right? But there's a terminology changes. It's Q. Answer is Q. Next. Next. How many values can a C function return at a time? At a time, how many values can return? Only one value. So in a function, it has to return only one value. It cannot return any multiple values. So maximum, so it's a wrong answer. So in the second option is it's a maximum of 2 values. No. 3 values is no. It's a maximum of 8. No. So it returns only one value. Right? The term push. Next question is the term push and pop is related to. It's a stack queue, both stack and queue. So some of the students have done both stack and queue, but it's a wrong answer because the stack only we are going to pushing an element and popping out. Okay. So please, some of the students, a lot of the students have done the mistakes in keeping your answer as C, but it's a wrong answer because in a stack we are going to perform the operation like push, pop, delete, display, like all the functions come on stack. So push and pop is a major part in a stack. Okay. The next question is postfix form to the following expression. So it's a very clear question because we are given the parenthesis. So first priority we go for the parenthesis as a rules. So what is it is a postfix. So first we'll talk about the operand E, F, then afterwards operator. Star is the operator, right? Here star will come out. Then afterwards here we have to sort this one. Which one? Here, right? D. Then D, next this is completed in the bracket, then D, then plus. Then think this one as an operand, this is an operand, this is an operator. Again it come under, we think this is an D is an operator and DF star is one operand, D is one operand, DF star is a one operand and plus is an operator. So postfix plus will come right side. So D, E, F star plus is the answer, right? Guys, next question. Insertion and deletion operation, the queue is known as NQ and DQ, right? In the previous question we talked about this question, the stack. In the stack we will go talk about the pop and push and pop. Insertion and pushing, deleting from pop. Here insertion and deletion in the terms of queue we will talk. The terminology called NQ and DQ. NQ for insertion, DQ for deletion. Next one. The stack can be implemented by using dash and dash. How many ways you can implement a stack? Basically, one is an array, binary tree. No, binary tree we did not talk about. The linked list and graph is also not. If we talk about linked list, we doesn't have. We do not talk about the graph. Arrays and linked list. Yes, this is correct one, because we can implement stack using an arrays and using a linked list. Queue and linked list, no. Queue is a topic. So queue will not come over. So answer is C. The answer is C for this one. Arrays and linked list. Next, when function calls another function. So one function is this. One function is this. Already is one function. It's calling a one more function. There is one more called function 2. This is function 1. This is function 1 calling another function. The details of previous function stored in stack. It's storing in the stack? Yes, it's true. So when the function calling another function, whatever the previous function is there, it has been storing in a stack. It's an what called a stack advantage. We can take it as a stack advantages. Right, guys? Do you have any doubts in this one? Whatever I given that basic simple questions. Anyone have a doubts in this one? Yes, true. Last option is true. So guys, if you have any doubts, raise a which question number. Which question you have doubt, again I will explain you. This is the result of the student who returned an quiz questions. So 189, 449, 449. 189 got full out of full. I just now projected the students here. This is a student. And yesterday we given some what we call a program which has to print in the reverse. So we given the 1, 2, 3, 4, 5 insertion. It has to print in a reverse order 5, 4, 3, 2, 1, and it should be use the time composite of O of n. O of n is nothing linear. Space composite O of 1. So we have given the 4 test cases. In that one, a lot of students are executed this program. I think at 223 around. We given the 4 test cases. The 4 test cases pass this logic. This logic has been written some of the student. So he was created one structure, and he written the one reverse function, one push function, one display function, and he called the main method. Okay, in the insertion he taken that one is an here in the push method he created a created a size with the help of malloc. Then you're trying to push in the data here. It's the logic for pushing the data. So actually whatever we written, we already saw explained about how to insert and insertion in a single list. Same thing, insertion is taken here, same logic is applied here. Then afterwards this is a normal printing method. Printing, here is printed struct no star temp is taken an entire complete stack. Then printing the data of next until while encoders. If while it is not equal to 1, this is going to print data. In the reverse, how it is taken is a logic. You apply region logic as is traversing all the last node. From last node is trying to print reverse. Suppose head is pointing at last, right? Here, suppose 1, 2, 3, 4. It's pointing at 4. Here 4. 4 means null. From null onwards, he was going to traverses. 5, 4, 3, 2, 1. This is the logic you return. You can check this code. Guys, if you have any doubts, please raise in the chat box. This is the logic for scanning. Then afterwards, whenever they encounter that one, how they going to pushing, how the value is pushing in a stack. In array, he was taking this is a logic. Whenever a slash arrows comes, then it will what is doing this one? It just why take only capturing only values, not this one. In this one, so guys, do you have any doubts? Please type in chat box. I can help you. Yes, Aman. Please change the input format instead of giving the input as a string. Give the data of nodes. It will easy to make the list. Yeah, actually, what I was saying is correct. If I given the numbers, if you're using 1, 2, 3, 4, 5, using the for loop, we can store in array. From the array, we can print the reverse order. Some of the students doing the logic like that one. What they will do, they will not use for a linked list. They will not write a program for linked list. They will write an array for loop, then printing in a reverse order. So even what happened that test cases will not make. Yes, we can make an array also, not an issue. But sometimes what will happen if they given some null, they given as a null in here in that arrow. Example, what you call here 5 hyphen null. Suppose in the test cases, hidden test cases, if you have hyphen null in array, how can you going to keep that one? So what happened in the test cases is going to fail. Suppose they are if I given the 10 test cases, 4 of the test cases like that one. 4 of the test cases are given as half and null. So some students what will do, they will write in a normal array with a for loop. So the test case will not pass. So suppose in the company they are giving this type of question, so you will write this whatever logic in the for loop like an array, then the test case will not going to pass. So for the main in the future companies coming, so we need a test case has to execute each and everything. So each test, suppose if I given the 10 test cases, it's 100 marks. So one test cases makes 10 marks. So if you're losing one test cases, you're losing 10 marks. Here I given only 4 test cases. Each carries 25 marks. But it makes a lot of time to convert from string to correct integer value. Yes. You have to use some libraries. Aman, there are a lot of libraries there. If there is that whenever that encounter some, if I read in the value, whenever I getting some arrow mark, it has to skip and it has to insert some value. So if you use the libraries, you can solve O of n. We are not using O of n square, right? O of n is nothing but a linear list. We are talking about linear list. And today also I kept one quiz, guys. One quiz is also there, completely quiz on today's quiz on the previous class, infix, prefix, postfix notation, everything. It's an all or example. I given the 15 questions and 10 minutes of time. Please make sure that when everyone has to start. I'm starting at 2:30 and I'm going to stop at 2:40. Yeah, if you started at 2:31, right? I'll close at 2:41. will do, I want to create a one, if you have any doubts, do one thing students, you can create a one WhatsApp group, two WhatsApp group, because a capacity of 256, if you have a capacity of increasing 3000 by using FS file export, you can do it. But I think so everyone can do that. But if you want to discuss all this type of questions, do you have any doubts? Please make a one group and post your questions in that one. We are definitely going to help you everyone. Yes, we can do it, Aman. Without library also we can do it often. But using a libraries, it's a very fast, means it take it time consumption very less. It's a very simple questions in fixed, prefix, postfix notation.